Section 5.1 is called using fundamental identities. If I talk about a question like sine x, oops, I forgot my x, sine x equals 0, there would be only certain answers that would work in sine x equals 0. Does anybody know any answers that I could plug in for x that would make this true? 0, pi, 2 pi, 3 pi, 4 pi. Any others? That's it. I got them all. How about negative pi? Would negative pi work? Okay. So we could actually say this like it would be just any number of pi as long as that number is an integer. Just any number of pi. So anyway, when we have a conditional equation like this, we are solving for x. That is not what we're going to do in this section. What we're going to do is we're going to have what are called identities. And identities would be statements that are true, equations that are true for all real variables. For example, and this is going to be the first one I'm going to write down there. If I do sine x, I know that sine x is equal to 1 over cosecant x, because sine x and cosecant x are reciprocals. So these two are equal, and it does not matter what x I use. These will always be equivalent no matter what x I use. So this is not an equation I can solve. This is always true. Where this first equation, the conditional equation, under these conditions, I can find answers. But this identity I can always solve. We're going to be focusing on identities for the first two sections of chapter 5. So what you need to know is you need to know the fundamental trigonometric identities so that we can use those to manipulate expressions. So the first one I told you, sine, it's u. It doesn't matter what variable it is the same thing as cosecant, 1 over cosecant u. So cosine u would be the same thing as 1 over secant u. Tangent u would be the same thing as 1 over cotangent u. Cosecant u would be the same thing as 1 over what? Sine u. So these are reciprocal identities. They're always true no matter what value of u, or x, or theta. Here's an example right here. If I have sine x and I multiply it by cosecant x, that will equal 1. But I want to show you how I will manipulate that so you can see it. If I have sine x, and instead of writing cosecant x, I'm going to substitute cosecant x for its identity that says cosecant x is the same thing as 1 over sine. And then I'm going to use my rules that I already know about multiplying fractions straight across. That gives me sine x over sine x. And then I'm going to use rules that I already know. If I'm multiplying and then dividing the exact same number, what do I get? 1. And you can see that it does equal 1. So that's where I might use a reciprocal identity to manipulate equations and expressions. They're called reciprocal identities because we are using the reciprocal. Yeah. Quotient identities are called quotient identities because the things that we are dividing, I'm sorry, the stuff on this side is dividing stuff. All right. Before I tell you this quotient identity, I do want to give you an idea of like where this is coming from. When we were doing things like tangent of theta equals, what's the formula for tangent of theta? What over what? Don't tell me words like opposite. Tell me the letters. Y over x. And when we were doing those kind of things, what was sine theta? Sine was y. Now it was over r. So I'm going to pretend that r is 1. This is the unit circle. So it's just y. And cosine in the unit circle would just be x. So our first quotient identity is that tangent u is the exact same thing as sine u divided by cosine u. And you just saw me how I got there. I used the y over x, which sine is y and cosine is x. So I just replaced those. So using the same thought process, cosine is x over y. So the quotient identity for cosine is going to be cosine x, or cosine u, sorry, over sine u. This is like the only time I use u's ever is in these notes. I should really change them someday. All right. Some other things that is important to know is how we write sine x times sine x. And I'm going to give you a real life example of this before I show you how you write it. Somebody give me an angle that we definitely can find the sine of really easily. 30, okay. The sine of 30 degrees multiplied by the sine of 30 degrees. So the sine of 30 degrees is half multiplied by half, and we get a fourth. So the way that we write squared for sine looks different than the way that you would write just x squared. I'm going to write it as sine squared x. And the reason why we have to write it that way is because when I multiplied these out, I did not square the x. I did not square the 30s. I did not have 900 degrees over here. I did the sine at 30 squared. That's what I did. I did 1/2 squared, and that was the sine that actually got squared. So that's why we write the squared before the x. But that's what it means. It means that it's sine x times sine x. So tangent x times tangent x is what? Oh, I can't hear. I forgot this is the class that forgot how to talk, right? Chris. Tangent squared x. Or sine squared x over cosine squared x. How did I get that? Caleb, how did I get that? Good. So tangent x, you just put it in your mailbox. Thank you. Tangent x is sine x over cosine x, and we're doing that twice. So multiply straight across, we get sine squared x over cosine squared x. Or if I wanted to just be all crazy, I could write this as this. Let me write you a note.
No, it's fine. I'm just going to work.
I know, but did you not hear the announcement today?
No.
So I could write it like that. Can anybody figure out what I just did? Did we figure out what I just did, Anthony? Mm-hmm. Right, the cosine right here, currently it's like 1 over cosine squared x, and secant x is equal to that. So I replaced 1 over cosine and made it into secant. If I wanted to, I could write this, secant squared x over cosecant squared x. How'd I do that? I moved the sign. Well, I didn't flip it, but I like replaced it. I substituted sine with 1 over cosecant. Why would I want to do any of those? It depends on what we're trying to accomplish. I'm just showing you that I can. They're all equivalent. It just depends what I'm trying to do. All right, so the next one, I can't talk. Cosine squared x over cosine over cosine x. This is the same thing as cosine x multiplied by cosine x over cosine x. The only way that you can cancel things out is if they can factor. If you can factor it out, then you can cancel it. If you can factor it out, then you can cancel it. So because I could factor the cosine out of the cosine squared on the top, that's why I could cancel it with a cosine in the bottom. So this is equal to cosine x. It's also equal to 1 over secant x. Okay. What could we do with this one? Anybody see anything we could do with this one? There's like lots of different things. Nick? Okay. Cosine squared x. Oh, you did a lot. Over sine x. How did he get cosine squared? Was that these two multiplied together? No. How did Nick get cosine squared? Nick knows how he got it, but does anybody else know how he got it? John, do you know how he got it? Couldn't tell me. Okay, I'm gonna, because you did 2 steps at once, Nick, I'm gonna take away that last step that you did, and I'm just gonna write your first step. So how did he get cosine squared x? Daniela, do you know how he got cosine squared x? The secant? So that's 1 over secant. And 1 over secant is the same as cosine. And that's why we now have 2 cosines up there, cosine squared. So then he also said cosine squared x over sine x. Mark, do you know how he got sine x on the bottom? Did you say put the sign on the top to the bottom? Is that what you said? I couldn't hear you, hon. Okay, so I don't see a sign here. Can you? Cosecant? Okay, so cosecant is equivalent to 1 over sine. But I'm just not writing those ones because 1 times cosine squared x is just cosine squared x. So that's what he's doing there. And again, you don't know what answer you want. There's probably even more things we could do here. Oh yeah, there was. Wait, was there? Yes, there's another one I'm going to do. Ooh, maybe somebody else can come with before I say it. There's another thing I was going to do. I know you can get it. I want to see if anybody else can do it. If not, I'll call on you. I know. I can see some steam coming out. There's some thought process going on here. Sarah, you got any idea, Sarah Nold?
You could do cosecant x over secant squared x.
Oh, okay. That's not what I was thinking, but totally. So there's another one I'm thinking of. That one works as well.
Couldn't you do cotangent x times cosine x?
Yeah, that's the one I was thinking about there. So she got cotangent x by using this one as cosine x over sine x, and then just using this part for the cotangent. And there's probably more. We're not going to spend all day just manipulating this. We're going to learn some more. Pythagorean identities. And this comes from when we were in the unit circle and we had a triangle and we had the ordered pair xy right here. Then we said x squared plus y squared equals the radius squared to get that r right here. But if the r was 1, it was the unit circle. So we had x squared plus y squared equals 1 in the unit circle. And x is cosine. And y is sine. So we are born with Pythagorean identity number 1, sine squared u or sine squared x plus cosine squared u equals 1. Now, there are a lot of different ways that we can manipulate this. And we're going to manipulate it together because when we manipulate it together, you kind of learn ways that you can do it on your own. This stuff you're going to have to do on your own. You won't be able to look at an answer key. An answer key might help you, but like you're not going to know how to do it unless you do it on your own. This is not like something that's going to come natural. Those of you that are just naturally smart. It comes from practice. Okay. So I have an equation and I'm going to show you how I can take this equation and just move stuff around and get another identity that looks different but is also an identity. So if I subtract sine squared from both sides, I get 1 minus sine squared is what cosine squared u equals. This is another Pythagorean identity. It all comes from the first identity, but it looks a little different. Ooh, this is true. This is true, right? Cosine squared u equals 1 minus sine squared u. Look, I can go back to that one we were just doing. Color. Let's go with this color. Where was it? Right here? This one right here. There's a cosine squared x right there. I could do 1 minus sine squared x times cosecant x. Now that I know this identity, I could switch it if I wanted to. Okay. Again, you only would do that if you needed to do it, and you're not going to know what you need to do until you've practiced. And we're just learning what the identities are today. Okay. Instead of taking away sine squared u, what if I took away cosine squared u? What if I took away cosine squared u instead? I would have sine squared u equals 1 minus cosine squared u. These are all Pythagorean identities. They're starting from that first identity and just moving stuff around. Okay, so using the above examples, could I ever get just -1 by itself? Is that possible? Is there a way to get -1 by itself? You know what? I changed my mind. I don't want to do that one. Stop thinking about it. How about negative sign squared u? Let's get that by itself. Is there a way to get negative sine squared u by itself? Caleb, do you know how to get negative sine squared u by itself? And you can use 1, 2, or 3. Just tell me which one you want to use to get negative sine squared by itself.
Use the second one
Mm-hmm.
and add 1.
Well, adding 1's going to give me a 2 here.
No,
Subtract 1. So if we subtract 1, that's going to leave me with a negative sine squared, right? So negative sine squared u is equal to cosine squared u minus 1. So right there, we just made another Pythagorean identity. I called it 2a because it was from the second one. What, Chris? Okay. We can make lots and lots of different identities by moving different things around. There might be at some point where you need negative sine squared u, or there might be a place where you need cosine squared u minus 1 instead of 1 minus cosine squared u, which you can see that these are different. So today we're manipulating and learning what things do. Okay, now I have some instructions. I'm going to take my original sine squared u plus cosine squared u minus 1, or equals 1, sorry. Sine, oops. I'm going to take that original one. I keep trying to change the color, but it's not. There we go. And we're going to treat this like an equation where we just divide everything on both sides by sine squared u. If you are dividing both sides by sine squared u, on the side that we have two terms, you're allowed to separate the numerator by distributing that denominator. And if I do divide everything by sine squared u, now I have sine squared u over sine squared u, which is 1, plus, can somebody tell me cosine squared u over sine squared u using one of our previous fundamental identities, what that one would equal? Caroline, can you tell me what cosine over sine squared over sine squared would equal from the first page? From the first page, there is a cosine. Oh, Jesus. I'm like zoomed out or in really far right now. From the first page, there is a cosine over a sine somewhere in the identities at the top here. You don't see cosine over sine? Mm-hmm. So since it's squared, I'm going to write cotangent squared. And then on the other side of the equation, I have 1 over sine squared u. And Nairi, can you tell me what 1 over sine squared u would be equal to?
Cosecant squared u.
Mm-hmm. Cosecant squared u. So you see how this identity looks totally different than number 1. Number 1 and 4 look totally different, but they are the exact identity, just manipulated. So that is another identity. I can also move stuff around. So maybe in number 4, I will take away cotangent squared from both sides. If I take away cotangent squared, I now have 1 equals cosecant squared u minus cotangent squared u. So if I ever have cosecant squared u minus cotangent squared u, I know that equals 1. There's another way I can manipulate it. I'm going to go back up to equation 4. And what was I going to do? Subtract 1 from both sides. So I have cotangent squared u equals cosecant squared u minus 1. This is the one where how could I get negative 1?
So, if we were asked like a problem like one of these, is there like a finished form?
No, there is not there's not a finished form. There is a starting form, and that is number 1. This is like the starting form. The finished form depends on what the question is, and we're not ready to try those questions yet. So it's not going to make sense until you see those kind. Right now, we're just playing around with manipulating equations. Okay. Now, can anybody see in questions 4, 5, or 6 how I could get negative 1 just by itself? Sarah Penny, do you see that? Mm-hmm. If I use equation 6 and I subtract the cosecant, then I will have cotangent squared u minus cosecant, oops, not co, CSC. And that would equal negative 1. Perfect. All right. I got one more of these manipulations. I'm going to start over with sine squared u plus cosine squared u. If you guys do have questions, please stop me while I'm doing this. Hold on. Yeah. Yep. That could be another manipulation. It's just multiplying both sides by negative 1. Mm-hmm. For sure. See, as long as you follow the mathematical rules that you should have learned in Algebra 1, Geometry, Algebra 2, you can really do a lot of different things. Okay, so this time we're going to divide by cosine squared u. Doing the entire side, cosine squared u, both sides. And then I'm going to separate the numerator. And then I'm going to use the identities from the first page to write new identities. Bell, Can you help me find what sine squared u over cosine squared u, what that could be replaced with? Good. Tangent squared u. Connor, can you help me with cosine squared u over cosine squared u? So what would be here? A 1, right. And Tyus, can you tell me what 1 over cosine squared u would equal? Not sine. Not sine. Was I saying 1 over cosine? Here's 1 over cosine here. So what's that one? And secant squared because it was squared, right? Okay, and then for number 8, maybe I will subtract tangent squared from both sides. From number 9, maybe I will subtract 1 from number 7. And again, there's more ways we could still manipulate these. There's one on here, I feel, man, there's one out of these identities that I feel that you should have memorized. Does anybody want to guess which one you should have memorized? Out of all 9 of these, which one do you think you should have memorized? The first one. That's the one you need to know, okay? The rest of them we can get by knowing the first one because we just did it. The first one's the most important one. I mean, it's the original. All right. So that's not what you're doing in your assignment. I mean, it kind of is, but not exactly. What you're going to do in your assignment is you're going to simplify expressions. We're going to take these down. Our goal is to have one trigonometric ratio if possible. Or actually, some of them aren't even trigonometric ratios. Some of them are just like a number. So I'll just say our goal is one number or trigonometric ratio. So if you can multiply it together, multiply it together. If you can add it together, add it together. Let's get rid of parentheses. Get rid of all operations if possible. Most of them you can. And then I'm going to go through how I would do these, and then you're going to use that to kind of give yourself a hint on how you would do them on your own. Okay, so the very first one, I'm looking at cotangent multiplied by tangent. Now we're trying to multiply these together, but I can't multiply them as is because cotangent x times tangent x is just cotangent x tangent x. So I'm going to manipulate it. Do you have an idea, Nick? What? Okay, so you are saying to take tangent. Okay, so Nick is saying, what if I left cotangent x here, but I changed tangent into its reciprocal of 1, not into its reciprocal, but into its reciprocal identity of 1 over cotangent x. So I'm allowed to substitute those because they are equal to each other. And if we substitute those, now we can multiply them together and have cotangent x over cotangent x. And if we multiply those together, then we divide cotangent x over cotangent x. We get 1. And that is one number or one trigonometric ratio. That is 1. Yes?
Could you also just switch the
Yes, and let's do it that way now. Okay. So this is not the only way you could do it. So Anthony, you said make cotangent into, let me zoom in so I could write bigger or write into cosine x over sine x and make tangent into sine x over cosine x. So if we do that, we'll have cosine x sine x over sine x cosine x, which is 1. Same exact answer, totally different direction. So there are different ways that you could do this. And if you come in and your homework matches mine every single question, I know that you just copied it. Because there's going to be ways where I might do it one way, but you're going to think about it a totally different way because we're different people. But that also means you have to communicate with me. If you look at mine and you look at yours and they're totally different, there's nothing telling you that you are also correct. So you're going to have to communicate. If you're not sure if you're correct, you're going to have to talk to me. Sorry. I know, that's like the worst thing. Okay, let's look at the next one. Cosine squared x plus sine squared x. What? 1? Oh, we're done already? Why? Because it is the Pythagorean identity. It is that identity. So we don't have to manipulate that at all. Like, that's what it equals. All right, next one. Everybody have an idea what we should do? Just looking at that, like, go into auto mode. What would you do when you see that? Don't worry about what our goal is. What do you normally do in math when you see something like that? John, what do you do? Yeah, like multiply it together. Let's multiply it together. So I'm going to multiply 1 times 1, which is 1. 1 times cosine x, which is plus cosine x. I'm going to multiply negative cosine x times 1, which is minus cosine x. Multiply negative cosine x times negative cosine x, or times, sorry, positive cosine x, which is minus cosine squared x. Combine like terms, and I get 1 minus cosine squared x. The middle terms canceled out because this is a difference of squares. They're conjugates. You guys remember this word at all? Ever? Maybe you didn't learn it. Last year was kind of a blur. Amy. Conjugates. Did anybody learn that term last year? Nobody's admitting to it. So conjugates are like when you have the exact same binomial, but one's plus and one's minus. Same first term, same last term, different signs in the middle. Those are conjugates. Okay. All right, so we got 1 minus cosine squared x. That's not one trigonometric ratio. Can we simplify that to one trigonometric ratio or number? Daniela? How'd you get that? Yeah, she's using that sine squared x plus cosine squared x equals 1. If we subtract the cosine squared x, then we get sine squared x. And that is one trigonometric ratio, so we are done simplifying that. We don't have to take it any further. Okay, so I've got fractions and I got subtraction. If I see fractions that are separated by subtraction, what should that tell you you need to do? Anybody? Chris? I see I need to get it to one trigonometric ratio or number. Right now I have subtracting things, and they're fractions. What do you have to do when you're subtracting fractions? We need a common denominator. We need a common denominator. Right now, sine squared x and tangent squared x have nothing in common. Maybe I do not want them to look like that. And you know what? I'm totally leading you guys down a path that as I'm talking, there's an easier way of doing it. But anyway, I'm going to stop. Nick, you had your hand up. What were you thinking before I even started talking?
Well, I changed 1 over tangent squared x to cotangent squared x, and then I changed that to cosine squared x over sine squared x.
Okay. And then what? And then you, what was the last thing you said?
I changed cotangent squared x to cosine squared x over sine squared x.
Right. Oh, to get the denominator same. That's the last thing you said, yeah. So he changed this to cotangent squared x. I didn't write it down. I should have written it. And then now we have denominators that are the same. So that we didn't even need to like find a common denominator and make it happen. We just needed to use identities to make it happen. Now that the denominators are the same, I'm going to do 1 minus cosine squared x over the common denominator of sine squared x. Still not one trigonometric ratio or number. Belle, do you see anything we could do? I feel like I just saw this somewhere. Mm-hmm. Okay. So like you'll keep using the same things over and over again, and they will be familiar to you. I do want to show you there was a different way. As I was talking about common denominators, I was like, oh yeah, there's a different way of doing this one. It's like, instead of thinking about them as fractions, if we changed 1 over sine squared x, if we changed that into cosecant minus cotangent, if we change that right away to cosecant squared minus cotangent squared, and then I go back to my previous page, whoops, that was way too far back, sorry. I go back to my previous page, cosecant squared minus cotangent squared. Here it is. It equals 1. So that probably would have been a faster way of doing it, but it doesn't really matter the method you use. What matters is that you are not breaking any math rules and you're getting to your answer. Cotangent x multiplied by sine x. So I would like you to try this one. I'm going to do it on the board the way I would do it, but that doesn't mean the way that you would do it is wrong. I'm just gonna put it up here because I'm recording this. I want you to try this on your own. If you get it and you're like, this is easy, then try the next one and just work ahead. I am gonna start talking at some point again. Okay, so I have cotangent x times sine x done. Is there anybody in this room that did a different first step than me? That did a different first step? Because I would like to do it more than one way. Is there anybody in here that did a different first step than I did? What'd you do?
I don't have a different first step.
Oh.
Like, I don't understand. Like, you have cosine x and then sine x and sine x. You can't do that sine x and
Mhm.
sine x. But like, you've also got a thing on the board that like you can't do that. I'm just really
Okay, so you can't do that unless it can factor. And factor means like unmultiply. Okay, so the thing that I have on the board, let me give you a bad example right here where somebody would do it and it's wrong. Bad, don't do this. And I can't do it with this one. Okay, I can't do that with this example. So I'm just making something up. Let's say I have cosine x plus sine x over sine x. This is what would kill the puppy. The difference between this one that we can do and this one that you can't do is that we are not factoring out a sign. It's added. Factoring would be like to pull it out by unmultiplying it. Okay, so the rules for being able to cancel is if you can factor it out, if it's being multiplied by the entire thing. Okay, and there are going to be people in here that will do that. So we've got to not be that person. Okay, thank you for asking. That was a very good question. This next one, I don't really feel like I have to spend a ton of time on it because as I'm writing this right above it, I'm noticing, that's the next question. Almost. Not exactly, but almost. You see it? The one we were doing right above it. So this one, I might have sine squared x over sine x. So what Chris was asking about, I can factor out a sine x from the top by unmultiplying it. And then on the bottom, I can factor out a sine x, and what's left over is just 1 when I unmultiply it. So then I am allowed to cancel it, and I just get sine x for my answer. Okay, so I'm going to stop talking for a moment again, and I want you guys to try the next one or two. Don't know how far you've gotten. 3, 4. There's only 4 left, so. So this one, I use the reciprocal identity. Oh, I use the Pythagorean identity first, and then I use the reciprocal identity. And I showed it both ways. You could change the cosines or you could change the secants. Did anybody start this one a different way? There's like a way longer way I think we could do it if we distributed first. And then change that into 1 over cosine minus tangent. And then like there's a much longer way you could do that. But all right. I'm silent again while you try the next one. So for this one, I took cotangent and I made it cosine over sine. I took secant and I used the reciprocal identity, 1 over cosine, and sine I just left. So I changed everything into cosine and sines. So that's like what I know the best. And because I changed everything into cosine and sine, then I multiplied it together, then I got the exact same thing on the top and the bottom, which is 1. Does anybody do this move in a different direction? Okay. Here's what you can't do. And I cannot see what's on your computers right now, but I know that there's some people sitting here wanting me to put down my first step, and then they're going to go off of my first step. You can't do that. You have to try something. If it's wrong, use an eraser or exit out and start over. But you have to start thinking for yourself. You cannot follow what I do. That's why I haven't written anything for this one yet. Put something down. I bet you anything I could put something on here that nobody thought of. Well, maybe not nobody, but. I just don't want to make this video like 10 hours long. That's why I haven't been walking around for every single question. And if you got that one, move on to the next one. Is it hard having to try something without really knowing if you're doing it right? It's hard, isn't it? Try something. We'll get to that one in a moment. Try something on that. That's what I'm looking at. Where's this subtraction sign? It's here. Okay, that's where you're getting a negative from that. So when you x, what happened here? So what's it equal? Oh, you're canceling this with this. So this is sine squared x here, minus what is this equal? Because that's not 0. Now, that's not one term. So what did you do from here to here? Because like you're missing a step. Okay, so that you are not allowed to do. In this chapter, you have to put all your thoughts down. Okay. Okay, I've seen a lot of different ways. This is good. Okay, I'm going to go through it. All right, so I did see quite a few different ways, but a lot of people getting the right answer or not messing up on the first step. A few of you messed up on a later step. The majority of what I saw going on was I saw sine squared x minus 1 over sine squared x times sine squared x. That's the majority of what I saw happening around the room. Some people changed the sine squared into 1 over cosecant, which is basically doing the same thing here. So our next step would be sine squared x minus sine squared x over sine squared x. Or if you did cosecant, it would be cosecant squared x over cosecant squared x, which is sine squared x minus 1. Now, if you have the answer cosine squared x, you are wrong. So the Pythagorean identity of sine squared x plus cosine squared x equals 1. In order to get sine squared x minus 1, I'm going to have to take away that cosine squared x from both sides. And I get negative cosine squared x. So the Pythagorean identities are always 1 minus sine squared or 1 minus cosine squared. If they're in the other order, then it's negative, that trigonometric ratio. I do want to show you I did a different thing in my head. I did a different thing, but nobody tried it this way that I saw. I actually saw this as 2 terms, and I factored out a GCF of sine squared x, and I was left with 1 minus cosecant. And then this 1 minus cosecant, oh, I did it a longer way. That was just a first step. I didn't go past my first step. 1 minus cosecant, I think, is negative cotangent. I think that's what it is. This is a longer way. And then I'd have to write, I'm going to run out of space. Here, I'll write it and then I'll just erase it. And then I was thinking sine squared x multiplied by negative cosine squared x over sine squared x, which these would cancel and I get negative cosine squared x. So either way, we're using the Pythagorean identities. All right, then some of you had time to look at the last one. So sine x multiplied by sine x over cosine x plus cosine x. So sine squared x over cosine x plus cosine x. We're trying to get this to 1 trigonometric ratio or number if we can. Right now, we have a fraction plus not a fraction. So I'm thinking common denominators might be helpful. What would the common denominator be? Cosine x, which means I just have to multiply this one by cosine x over cosine x. So I have sine squared x over cosine x plus cosine squared x over cosine x, which I'm going to have to go up here because I ran out of room, equals sine squared x plus cosine squared x over cosine x, which is 1 over cosine x, which is secant x. Sorry, I should have spaced it better. Did anybody get that answer, but do it a different way? Did anyone get that answer, but do it a different way? Yes.
How do you go from sine squared x plus cosine squared x over cosine?
Hold on. Let me number these steps. How'd I go from which step to which step? 4 to 5. Oh, so sine squared x plus cosine squared x is the identity that says it's equal to 1, the Pythagorean identity. The one that you should know. Okay. So that's the end of the video. We have a worksheet that is similar to this stuff for your assignment. And then if you need any help, you're definitely going to want to ask about it, because this is laying our foundations for 5-2. And then what did I say about 5-1 next class? You're going to have a short quiz. Oops. You're going to have a short quiz. And the short quiz is going to be just like these notes, where I'm going to give you something like this, and you're going to type in secant x for your answer. Okay?